Can you guys hear me okay? Yeah? I see Travis put on a vest. Yeah, it's a little bit cold in here. It's colder than the rest of the building. Thanks for coming. End of day, what is it, 2 or 3? It depends on how you count, I guess. I'm going to talk to you guys about an interesting issue around safeguarding access tokens in single-page applications. And we're going to look at sort of a pattern that we call the token handler pattern that we can use to alleviate some of these issues. Actually alleviate them to the extent that we don't really get the token in the single-page application. Actually, we do, but it's not usable directly. But let's start with a very short intro. I'm Jonas Igbaum. I am Director of Sales Engineering at a company called Curity. I am originally from Sweden, if you pick up an accent, but I've been in the US for the last, 18 or something years? You lose count after 10 or so. I'm based in the Bay Area for now. I've lived in Chicago for a bit too. So we're going to start by looking at sort of how do single-page applications traditionally run OAuth or OpenID Connect flows. We take the problem of the token out of it, but what does it look like when we run one of these flows? And we actually do get a token in the browser. And then we'll talk a little bit about why that's not necessarily great. Not running the flow, but why it's not necessarily great to keep that token in the browser in itself. And some threats and concerns and best practices around what we can do to fix it. And we're going to look at using an API-driven SPA security model, which is essentially this token handler pattern that I'm talking about. I am also planning to run a demo at the end so we can see an application that actually uses this. The nifty thing about this pattern, though, is that it's very silent and sort of non-intrusive to the user. So a demo is kind of like, look, I logged in, nothing really happened. And so we'll try to look under the hood and can see what the cookie is and what happens. We call some APIs and stuff like that. So an original single-page application. Sorry, I've been saying SPA. I'm assuming people understand what SPA is, right? It's not the place over here by the pool. It's a single-page application. So an original single-page application, OpenID Connect flow, runs something like this, where you have web hosts, some kind of web content delivered to the single-page application, and it needs to typically have data accessible from APIs that it needs to call, right? And in order to call an API, in these days, we use OAuth, right? Who doesn't use OAuth? Anybody in here don't use OAuth? If so, come talk to me later. We'll sort that out. So what happens there is that we have these authorization server. We do the song and dance of authenticating and running through that, and eventually we get issued an access token into the single-page application. It contains probably some scopes and claims to provide access or gain access of data from the API. The application here needs to hold this token somehow, right? Because it needs it accessible to put it into the request to the API. There's a bunch of different ways a SPA can do that. They're all, to various degrees, not that great. You can hold it in memory, you can persist it to disk, and a couple different variants. They're all susceptible to one or other attacks in itself. Or they have problems with if the session closes, well, the token's still there if you persist it to disk, for example, and then the actual disk access is susceptible to leaking the token in itself. So the benefits of a single-page application here is like it's productive development, right? You have a content delivery system that delivers the content, for example, to the application, and you have a huge focus on the sort of UX and the front end of the application in itself. it separates the concerns of front-end development and an API and the content, right? So you have clear separation of concerns within the components, and you can deploy this application pretty much anywhere. It's a simple application, right? So that's part of why single-page applications have become extremely popular. There's been some recent changes around cookies, and why do I bring this up? Well, this token handler approach involves leveraging some of the more recent, these days they're not even all that recent, but in the history of cookies, sure, they are very recent, right? So we have had introduction of much stronger cookies, same-site cookies, where we now see that this is sort of, could be an actual good way to protect tokens. And we can leverage really strong cookies to protect these tokens. And we can protect against some of these common attack vectors like cross-site scripting and request forgery attacks that can be used to steal the cookies or the tokens and use the tokens to call APIs at a later stage. Other problems here that we see with single-page applications is, I don't know if it's started happening that much yet, but third-party browsers are starting to sort of, we're going to start dropping these third-party cookies. So first-party cookies is the way to go, but SSO cookies are third-party cookies. So we're going to start seeing issues around that. Other parts, JavaScript options requires refresh tokens in local storage. So that's sort of how single-page applications handle a refresh flow, right? You need a refresh token to be able to execute a refresh flow to obtain a new access token if the access token has expired. And there we have all sorts of debates on sort of how long should your access token be valid for, how long should the refresh token be valid for. That's a huge depends, but on the use case and on the application in itself. I'll cover a little bit on how this token handler pattern can handle refresh flows as well without actually putting necessarily a refresh token in the application in itself. Backend for front end, who's familiar? There's quite a bit of hands up. Yeah, okay. So jokingly early on when we talked about SPA and backend for front end, sort of the phrase came up like bring your BFF to the SPA. Then we kind of minted the token handler pattern or the wording instead, so the BFF part went away, but it's still funny, I think. So the backend for front end approach it's still there. The token handler pattern is a backend for front end essentially, right? The components are. So the idea here is that we have a backend component that issues cookies on the behalf of the single page application. So we have sort of a ready-made component that can issue the cookies. So if you have single page application developers, they don't have to deal with cookie development and cookie issuance and things of that nature. Parts of this is described in this OAuth 2 for browser-based applications. So there's much, much more detailed on sort of not the back-end for front-end approach for single-page applications. So how do we integrate this into a single-page application? This, remember the first architecture of an OAuth flow in a single-page application. This is sort of the new architecture of that. The parts here that sort of is the token handler is separated into two parts. There's an OAuth agent and an OAuth proxy. Both of these two things makes up the token handler. So the token handler in itself is not sort of, here's the token handler, we deploy it and run it or something like that. It is these two components. And they can actually be here, they look like they're sort of co-located on what looks like an API gateway. It doesn't have to be, and they don't have to be co-located either, to be honest. So the components here is we have some form of authorization server. We have our APIs or microservices that this SPA wants to get data from, right? The OAuth agent is the part of the token handler that is responsible for running and executing the OAuth flows, the OAuth song and dance. This is kind of it is an OAuth client to a great extent. So the SPA will sort of initiate this. There's some endpoints here that we need to talk to, obviously, to kind of start and initiate the flow. The OAuth agent will then run through the flow with the authorization server. There's a return back to the SPA because we need to perform some form of user authentication, and that is server-side rendered here on the authorization server. So there's sort of the SPA will get the redirect so that it can present the login screen for the user. When all is said and done, what happens is the authorization server issues the token to the OAuth agent. The OAuth agent is the part that's responsible for taking this token, encrypting it, and putting it in a first-party secure cookie that it returns back to the SPA. So now all of a sudden the SPA has sort of a tightly coupled cookie that is HTTP only, can't be read by JavaScript, and it holds a strongly encrypted access token that it doesn't have the keys to decrypt because the keys are not available here in the SPA. So even if you lose that token, it's still encrypted. When the SPA needs to talk to the API to get its data from the API, it passes the cookie. This goes through an OAuth proxy, which is the second component then of the token handler, right? The OAuth proxy has the key to decrypt the cookie. So it will decrypt the cookie and then by that get access to the token that it can then pass on to the API. So in a most common world, this OAuth proxy would be some kind of plugin on an API gateway probably, like Azure API Management, AppG, Kong, Tyke, Nginx, whatever it might be. So differences here with some alternative solutions of handling this is that you separate the web host from the cookie issuance. So you have a component that's like, at least in our case, I would call it developed by security professionals that understands this, right? You have an API-driven cookie, best support for like micro UI architectures. We'll look a little bit later what that looks like too. The SPA calls the API through an API gateway or a proxy, and the SPA remains in control. It doesn't really change much on the SPA side, on the single page application side. Like the user is not aware that this is going on, obviously, and you don't have to change that much. The code on the single page application becomes extremely easy because it's just passing on a cookie. It doesn't have to deal with sort of what do I do and how do I store the token and all of those things. The OAuth agent, I mean, this is just a little bit for information. The OAuth agent would expose a couple of endpoints that the single page application can then consume and interact with, right? So we have a start endpoint that initiates the flow, right? We have an end endpoint, which is actually when the SPA tells, okay, I'm done with the authentication, let's call the end, and that's when it gets the cookie, essentially. But then there's things that can happen throughout the lifespan of the single page application too. Like you might need to get user claims or user info information, or you might want to proactively log out the user of the application in itself. I'll demo some of these in a little bit. So now the login flow ends up like this. It's a different version of that architecture, but it shows the flows a little bit better, right? So we have the single page application that initiates the authentication, the login with the OAuth agent. The authorization request URL is returned to the SPA that performs that login. It gets the authorization code back that it posts to the login end that the OAuth agent then takes care of to like talk to the authorization server and get the token. encrypts it, and then returns the cookie back. So this is sort of the flow of a login and the endpoints that the SPA is consuming throughout that flow. The cookie that the SPA receives is a secure same-site, strict HTTP-only cookie that is encrypted. The domain here doesn't really matter what that is, but it operates with it's a same-site cookie, so it has the notion of the domain, and it can operate with the not subdomains, but with like sibling domains or whatever you want to call them. Not sure why I put an encrypted cookie in here, because it's pretty useless, but that's roughly what the cookie would look like to the single-page application. It's very small, especially if you use opaque access tokens, which I think you should do. I don't think it should be a JOT that gets sent out here. I'm not saying that it's a debate between what an access token should look like and what kind of format it should be, but depending on the application, there's a lot of strong arguments that it shouldn't be a JOT. In this case, though, it's encrypted, so it doesn't really matter, but if you send it as a JOT to the SPA, it's just going to be a lot of information that the SPA is not ever going to use, and it's going to be a larger cookie than needed, right? There are ways to issue this as an opaque access token, meaning it's just like a GUID and a string. And then remember in that flow where we go through in this flow, when we go through the API gateway and the OAuth proxy, we could actually take the cookie, decrypt it, we get the opaque token, and then we do an introspection against the authorization server and receive a JOT back that we then pass on to the API. So we don't hold the encrypted JOT representation in the cookie. We hold an opaque token in the cookie and then replace it as part of the OAuth proxy mechanism of decrypting the cookie. Yeah. So we kind of already covered this. The SPA then, when it needs to access the API, it goes through the API gateway that proxy and that has the OAuth proxy component that then can perform token introspection, for example, and has all the protections of CORS and whatnot. So the security results around this is you get sort of website level security in the single page application. We can, with this, also leverage, although the SPA is completely unaware, but we can leverage the FOPI type of approaches of all the abbreviations, JAR, JARM, etc., because that happens between the OAuth agent and the authorization server, and the SPA is sort of willfully unaware that this is going on, right? This doesn't solve cross-site scripting, but it's protecting the cookie, it's protecting the token from vulnerabilities that are implicated by cross-site scripting. You should still take all the measures that you need to protect your single-page application in general when it comes to cross-site scripting. There's definitely ways that cross-site scripting could potentially grab the data that the SPA holds that it actually receives from the API and whatnot. But we've protected the access token from being sort of used by someone else to call the API. In essence, that the token gets lost or stolen and being used to call the API. So, can you see that kind of okay? You guys don't really have to see everything that's going on here at the bottom, though, but not right now. I have lost my mouse cursor. Here we go. So this is a super simple single-page application. I'm running this all locally. It's a bunch of Docker containers. It has the single-page application. It's got an authorization server. It's got a Kong API gateway with both the OAuth agent and proxy running on it. Doesn't have to be that way. We can, and it has an API that the SPA can call. So for a very simple demo, it's a fairly complex environment. But what we can do here is, if I click login, now we've got that redirect from the authorization server to authenticate. And now it's up to the authorization server what is configured for authentication. So this is sort of outside of the scope of what the token handler does, right? But I'm going to log in with my account here. And now we're authenticated. We get some more sort of functionality in this single page application. I can call sort of the claims endpoint. And in this case, I'm only getting one of the claims. It's for prototype purposes, right? So we can get all of the claims. I can call the API. We passed the cookie to Kong, which has the proxy that decrypted the cookie and called my backend API and fetched a bunch of data, right? User info, it's just another endpoint. So since we don't have, this is essentially what you have to use because we did not send an ID token back to the single page application, right? So we don't, the single page application might need some of this user information, and that's the way it can get it outside of sort of holding an ID token in this case. Both the user info and claims. Another cool aspect here is that we could open another tab, and it still works across tabs, even if I break it out. And we can sign out here, meaning I've now destroyed the cookies. So I'm automatically signed out on the other tab that I was on, right? I forgot to show the actual cookie. And I logged out, so now it's gone. So we can log back in here. This is the cookie down here, so you can see it's a strict HTTP only cookie. But like I said, the demo aspect of what actually happens underneath the hood is not super interesting. I mean, there's a lot of things going on in there, right? But it creates a pretty simplistic single page application that works beautifully with holding a cookie instead of a token. So it's leveraging a cookie. It's representation of a token. And that was that. I be happy to talk more about this. I'll be around. I'm actually talking tomorrow morning too. Just like the previous speaker, I was going to say, come talk to us at our booth, but our booth doesn't exist anymore. But we have a lot of content on sort of the token handler approach and how we do it at Curity on our website, curity.com. I'm running a webinar specifically on this topic where we're going to demo a little bit more of the components around this that we are developing at Curity that handles all of this. Like the actual OAuth agent will be running within the Curity server, and we are developing plugins for the major API gateways in the market. So we'll talk deeper on this in a webinar that's going to be on June 18th, I think. So sign up for that. Sign up is on our website, and come listen to more about how we see that this can help secure single page applications further. Thank you.